Hello my dear friends, welcome to our channel, welcome to our world of science. So let's start this chapter, elasticity. What exactly the elasticity is? So without wasting our time, I'm entering into this class and welcome once again to our channel. So I'm starting with an example my dear students. So see here, it's a spring. Is this visible? Yeah, I think it's visible. Yeah, done. So see here students, it's a spring. I'm holding the spring at one end. At the second end, what I'm going to do is that I'm going to pull the spring. As I'm pulling the spring, you can see the change in the size of the spring. That means it is getting elongated. Whenever I am pulling the spring, it is getting elongated. You can see the elongation in the spring. So I am applying the force externally in order to elongate the spring, in order to change the size of the spring. That means I am deforming the spring. This spring is an object. This spring is an object. I am deforming the spring. So deforming means what? Those who don't know, please listen this one. Deformation is nothing but changing the size or shape of the object is only known as deformation. So I am doing the deformation here. What I am doing? I am deforming the spring. How I am deforming the spring? By applying an external force. By pulling the spring, I am deforming the size of the spring. You can see right now the size of the spring has been changed right now. What is the reason behind it? What I done? I applied the external force. If the body is getting deformed by an external force, then that force will be known as the deforming force. I will show you one more example. See here, I am going to just apply the force at the top of the spring, and I will see the change in the shape of the spring right now. You can see it bends. So you can see the change in the shape of the spring. That means what I applied? I applied the force externally, and you can see the change in the shape of this spring. That means whatever the force applied, it is deforming this object. That means what I can say that force is that deforming force. Why I am talking about the deforming force mostly is that it has a vital role in the elasticity. You will come to know what is that role actually is. See here, I am changing the shape of the spring. I am changing the shape of the spring. But once after the deforming force have been removed, see, it is coming back to its original position. It is regaining back its original position. You can see one more example. As I am pulling the spring, it is getting elongated. And after the removal of my deforming force, it is coming back to its original position. So, what I conclude from this is, what I am concluding from this spring, from these two examples, by elongating, by changing the size of the spring and by changing the shape of the spring, by applying a deforming force, I am observing is that when a deforming force is removed, the spring is regaining its original position. This spring is regaining or restoring its original position, coming back to its original position once after the deforming force is removed. So what elasticity is? It is what elasticity, my dear friends. It is what elasticity. Elasticity is nothing but the tendency of an object to regain its original configuration once after the deforming force has been removed. Once you are removing your deforming force, it should have to regain its original position. As I have shown two examples to you, one you would have seen the change in the size of the spring, but once after the deforming force I removed, you would have seen that the spring is coming back to its original position. And the second example, I show the same with the spring. I changed the shape of the spring by applying a deforming force, and once the deforming force I removed, you would have seen that the spring is coming back to its original position. And it shows that the spring has the elastic property. It shows the spring has the elastic property. Why I am saying it has elastic property? What is elasticity? Now only I given you a simple definition. The tendency of an object to regain its original position, to come back to its original position once after the deforming force has been removed. I am just writing down here. You just note it down. The tendency of an object to regain its original position or original configuration Once after the deforming force is removed, once after the deforming force is removed, you can see the regaining of its original position of the object. If the object is regain its original position, once after the deforming force is removed, then that object is having the property of elasticity. If that object is not regaining its original position, if that object is not regaining its original position, then we will call that object as plastic, and the phenomena will be known as the plasticity. That means if we are deforming the object, if we are trying to deform the object by applying the deforming force, after applying the deforming force, if we are removing the deforming force and that object is not able to come to its original position, to regain its original position, then that phenomena will be known as the plasticity. So it will get, in plasticity, the object will get permanently deformed. If you are removing the deforming force too, then also it will not regain its original position. It will be in the position where we apply the deforming force to change the shape. Once the shape has been changed, that means it will be known as permanently deformed. That phenomena will be known as the plasticity. So what is elasticity? You would have known till now, and you too know this, what is plasticity. So elasticity and plasticity has been explained, my dear students. Elasticity is nothing but it is a tendency of an object to regain its original position once the deforming force has been removed. So if the deforming force has been removed, if it is gaining its original position, then it will be known as the elasticity. If it is not regaining its original position, then it will be known as plasticity. I have a good question for you, my dear students. Just listen it out. Yeah, I'm writing here. What the question actually is, I'm having two elastic objects. One is rubber and another one is steel. And I'm asking you which is having or which is showing more elasticity. Whether rubber is showing more elasticity or steel is showing more elasticity. I know everyone will be thinking that the rubber is the only one which will show more elasticity, as everybody knows about the rubber. I am too having the rubber, my dear students. I am too having the rubber. You can see here. I am having this rubber, see? Yeah. So what actually the example is that? You can see here. What I am doing is that I am just elongating this rubber. You can see I just apply the deforming force because the size here is the changing. That means whatever the applied force is, it will be known as deforming force. As I apply the deforming force, you can see the change in the size of the rubber. And once I'm removing this deforming force, you will see it is coming back to its original position so fast. So everybody will be thinking that rubber is having more elasticity when compared to the steel. And now I will show one more example to you. Please come here, my boy. Yeah. Just hold it down, this one. At the end. Yeah. See this example? Yeah. It's coming. Yeah. It's visible. Yeah, it's visible, my dear students. Yeah. My dear friends, see this one. What I'm going to do is that now the rubber ends has been fixed. That means it is fixed at both the ends. What I'm now going to do is that I am applying the deforming force here. You can see here, I am applying the deforming force here. It is coming back to its original position. You can see here. I am applying the deforming force here. It is coming back to its original position. And I am comparing this with the steel. As you know, in guitar, see, it's a guitar. I'm not going to play the music, my dear friends. I'm not going to play the music. You just listen it out. What I'm saying is that it's a guitar, and the strings which you are seeing here is actually made up of steel alloys. So you can see here, the same I'm going to do is that now the ends are fixed. That means they are holded by there. What I'm going to do is that I'm just going to deform the spring position. You can see here, I'm trying to deform the spring position here I am trying to deform the spring position here. You can see here, and see, I'm just removing the deforming force, and you will observe that it is going back to its original position faster than the rubber. You can see here, I'm once again deforming the steel, and this steel alloy is going to its original position so faster. That means exactly the steel is having the more elastic property than the rubber, and it has been proved now. I'm not having the speed machine to calculate how fastly it is going on. I'm just showing you a simple experiment. What I did is that I'm just holding the rubber with my both the hands. Now now both the ends are fixed, and I'm just giving a deforming force, and it is coming back to its original position. And in the guitar, the two ends are already fixed. In that too, I'm giving the same deforming force, and I'm observing that I'm observing that it is going back to its original position. The steel alloy, which is a string in the guitar, it is going back to its original position. It is regaining its original position more faster than the rubber. The steel is having more elasticity when compared to the rubber. So which is more elastic? Steel is more elastic when compared to the rubber, and hence it has been proved now by a simple experiment.